We've seen how to declare and assign values to variables that could hold integers. But what if we wanted to store a value that wasn't a whole number? What if we needed to store 4.7 or 98.1? In this video, we will introduce a new data type called a double that allows you to store floating point values. Here we declare an integer variable named temperature and set it to 32. When I press Next, we see that the variable of type int has been declared and that at its address is stored the value 32. Now what will happen when I press Next again and this statement is executed? Have you made your prediction? Is that what you predicted? The value in the variable temperature was set to 98. The 0.1 was not saved. Only the integer value was stored. If you try to assign a floating point number to an integer variable, the number will be truncated at the decimal point before assignment. The fractional part will just be discarded. If we want to work with non-integer numbers, we can use another variable type called a double. The only difference with declaring a double variable is that we change the type keyword. Now let's run our program again. You can see in the visualizer that it stores a non-integer result. Notice that on the stack, the double has two addresses and takes 8 bytes of memory. It takes double the memory of an integer, hence the name. The double type is very useful if you want to work with real numbers, but it has limited precision. Remember that variables are given a certain amount of space in memory. Because of this limited space, a double value has a limited number of significant digits. One thing that might surprise you is that when you perform division using two integers as the operands, the numerator and the denominator, the result is not a double, but just an integer. Let me demonstrate. Suppose I add this line to my program. I'm declaring a double named quotient and assigning it the result of 9 divided by 4. What do you expect to see as the value of quotient? Did you expect 2.0? Or were you thinking it would be 2.25? The result stored in quotient is 2.0 because the operation 9 divided by 4 gives the integer result of 2. And then that integer is converted to a double by the assignment statement. We will learn more about types and converting between types later in the course. But before we finish, I'd like to introduce one more operator. The modulo operator, represented with a percent symbol, gives us the remainder of an integer division operation. I would say this line as modulo is assigned 9 mod 4. Some people would say 9 remainder 4. When I execute the statement, we see that the quotient was 2 and the remainder was 1. The result of our integer division is 2 with 1 left over. Add 1 over 4 to 2 and you get the result of 9/4.